All right. This is Mason, and today we'll be doing, well, I guess the final project for Fluent. And this is part C of the fluid wind tunnel simulation. And this one will be adding a thin plate. So first, fluid flow fluent, uh, change this and then do whatever you prefer. Now, time to go through this. Lines. Let's zoom in real quick. Oh, dimensions, horizontal. I did it again. Holy moly. So I can do this, but I do have to modify. Do have to draw a new line. I don't know why I did that. And then I'll do dimensions again. First, I'll be, what is it? 1.176, 1.212, 0.5 is 748. Once that's done, we'll just draw a line from all of them. And then we'll also add a construction point there. And then we go to constraints. Just click midpoint. Oh, no. Oh my gosh. So we'll add this constraint. I think that's fine. And we just draw some lines. Gosh, this is brutal. Just like this. Oh, why? Here, 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 here. Okay. Let me just delete this really quick. I don't think it matters when to do this. I'm just gonna do this now. Just like that. And then once that's done, you then just go back to constraints. Midpoint here, here, midpoint here, that's there. Um, Now you just connect. Start deleting a bunch of stuff. Delete. Delete. Delete, and then you just do a small plate. So we'll draw a very small rectangle. That does look small because, I mean, shit, it doesn't look small. Horizontal. What do we make it? 0.5. And then, vertical, you make pretty tiny. What is it? Where do we have it? Oh, it's the length divided by 1,000. So it is a very small, very, very small, or thin, sorry. What is this? This would be 10. 1, 2, 3, 4. Um, can I constrain and just do no? Well, this is what we got. So we'll then do concept, surface from sketches. Okay, I'm stupid. This needs to get out. Where's the box select? I forgot I can just box select it. Hold on. See, then. Right. Next, we will go to mesh. This is also a pretty basic mesh. I just did a few things. So first, it's a basic mesh, triangles, generate. easy. And then we'll do another one, just sizing mesh this time. So we'll do one, two. The top. Oh, no, no. Holy. Okay, well, I just messed that up. You just make that 1,000, and again, hard, all that fun stuff, and then you'll just click generate. Right, and then next we'll do another edge sizing. One of them. Wide the both edges. Number, and I think I just did 50. Yeah, it's just 50. And then, of course, hard behavior. Generate. And then we'll just change it to 0.01 and generate. All right. Now that we have this, we can just name stuff now. And that's outlet. And on the wall. I think did I just name this flat plate? Yeah, I just named it flat plate. Just like that. And then we'll exit out of that. And then we'll just go to my setup. It's loading. Okay. And just like the other ones, just need the velocity pressure and a couple different things, but we'll get all that settled. Let this run. Right. Yeah, materials again, make sure ideal gas, reference values should all be good. Set inlet to 5.625. I think that's kind of it. Initialize, and we'll just run. So this is the wrong thing. All right, next graphics. They just want no pressure. Let's do this. So what pressure looks like. You can see at the flat plate, it's pretty high right here. I just crashed my thing, so all right, I just crashed mine. Great. That's oh, I'm keeping this in the video because I just don't care. Set up again. That's actually I'm recording, yes. If I'm not recording, I'm gonna be okay, good. Oh, this is just torture. This sucks. Do I have to do all this again? All right. Time to run it one more time. All right. They merged. Sure. Graphics now. Contours. First one we'll do pressure. That's what they want. Um, I cannot zoom in, so this is the best I can do. At the top, that's fine. All that. It looks fine. All right. And then this will be the velocity one. So this is a little more rough, but you see we have that big line because of just no slip. Well, and then you'll see it has a good hit right here. All right. And then next, I got to do the wall shear graph and coefficient. The other one, okay, this one's saved. So here's wall shear. This is what it looks like. I think wall shear is fine. Looks just like this. And then skin friction is the one we will have to change. So here is skin friction coefficient, sorry. With this, we'll have to again write this and change it because they use the wrong velocities. Let's do drag coefficient. Oh, we need the drag, and then we have to recalculate the flat plate drag force. Point 335. That's our drag. Now, what we had to do with the graphs is write them in the file, save them, do all that fun stuff. Yeah, so we're done with this. If you did it correctly, you should be able to look at them in Excel now. We'll do wall shear first. Oh boy, I gotta find wall shear. So I inputted it like that. And here's my wall shear. Ooh, this right here. And then the skin friction, because wall shear is correct. Skin friction, you do have to, again, do the equation, change it, and it'll look like this. Just like that. And that is pretty much it. I'll show my final report. Um, it's my final report with everything. I'll skip all part B, and here's part C. Weight, pressure, moisture stress, skin friction, and then remember that number, we just put it into this formula right here, and we will get that for our drag coefficient. So yeah, that's it. And